Hey everyone, welcome to another BTM screencast. Today we'll be going over chapter 14, which covers saws, drills, and drivers. So first things first, always safety. Always wear eye and hearing protection. Do not wear loose clothing and secure whatever material that you're drilling or cutting well. You don't want anything flying away, you don't want stuff getting kicked out, you don't want your clothes or jewelry or hair to get caught in anything that's rotating. Always keep your tools sharp. Believe it or not, dull tools are more dangerous than sharp ones. Stay alert and have care for yourself and others in your area. Remember, safety is a team effort. Don't distract others, no horseplay. Always use a cord plugged in to a GFCI. Do not use frayed cords. This is very important. Never use frayed cords. Unplug tools before touching cutting surfaces or edges. Circular saws adjust to various depths and are used everywhere on the job, and they're also a very dangerous tool on the job. You can cut compound miters and angle cuts. So you could see that this gentleman here is just going straight across, which is fine. There's nothing wrong with that. Right where he's at. But you can also cut a bevel, and you can also cut a miter with a circular saw. So these are two that you'll see in the lab. One is a direct drive, which we use most commonly. These blades are 7¼ inches in diameter. And we have the worm drives down here, which we don't use as frequently. And you won't be using these in the lab. And here's different cuts that you can do with a circular saw. You can see, depending on the way that you have it laying down, if you have it vertical, this is your bevel. If you have it laying this way, this is your bevel. And of course, you have your miter angles, which are cut. And it shows them here and here. See, there's a number of circular saw blades. Most of them that we use here will be the combination. And we use the carbide tip blades. They last longer than many other ones. Always wear safety glasses, and in this lab you also must wear hearing protection. Always rest forward the end of the base on the work, and the blade clear, meaning it's not up against the stock. You're able to hit the switch and start the saw. Once the blade gets up to speed, at that time you can feel free to begin pushing through. And the author says follow the line closely, and here up until you get your muscle memory down, you will be using a guide to cut with. Always cut as close to the line as possible. And you can see right here, they're cutting, it's just a nice cross-cut piece. And in this picture, you can see the fall-offs are able to fall off instead of getting pinched, and the end that's going to be the piece that he needs most likely is well supported, and you don't need to worry about your blade pinching or your saw kicking back. When the cut is completed, release the switch, and our saws, it's always a trigger. When cutting at an angle, sometimes you need to take back the guard by hand, and this guard and everything else is on the circular saw anatomy. In this case, it's this guard right here. Sometimes you need to start it by hand. Compound miter cuts can be made cutting across at an angle and with the base tilted. And again, these are things that we'll go over more in lab. Plunge cuts are extremely dangerous, and it's not something that I will have you do right away. When you do make a plunge cut, lay out the cut and adjust the saw for depth. So for this class, anytime you adjust your circular saw to cut, it will be 1/2 or 1/8 of an inch below the stock that you're cutting. Wear eye protection, and in this lab you must also wear hearing protection. Hold the guard open, the one that we went over just a little bit ago, and tilt the saw up with the front edge of the base resting on the work. With the saw blade clear of the work, squeeze the trigger and start the saw. And you can see this is the front that you tilt up, and the blade's not spinning, so that's okay. But you can see that they're manually bringing this guard up so it doesn't get caught. Lower the blade and move the saw forward to one corner that you're cutting. And reverse the direction and cut into the corner. Now, it's not saying move the saw backwards. You're going in the opposite direction. Continue in this manner to cut the other sides. Do not cut moving saw backwards. Never, ever, ever use the saw to cut in reverse. So here, in this picture, he will be cutting in this direction, and if he's cutting a box out, then he'll be cutting in this direction, and then this direction, and then this direction. But never under any circumstances should you use the saw to cut backwards. Jigsaws, another saw that we'll be using in the lab. So you will see what they look like in a little bit. The length of stroke and motor amperage determine the size and quality of the saw. The ones that we use in the lab are of good quality. Some saws can switch from up and down strokes to orbital motions. We do have these in the lab. We have both. The base may be tilted to make bevel cuts, so very similar to a circular saw. Blades are available for fine or coarse cutting in wood or metal. Now, the less teeth that it has per inch, the coarser it is, and the faster it cuts. And you can see this is a jigsaw that they have here. Here's the base. Here's the blade coming through. And you'll be able to take this and then go along your line, and you're able to do nice radius cuts. Always wear eye protection. This saw isn't as loud as the circular saw, so hearing protection is optional. Hold the base of saw on the work and squeeze the trigger. Again, always make sure that your blade is clear of the material that you're cutting when you start. Outline your cut and make sure that the piece that you're cutting is secured with clamps. And then you can begin to push a saw into the work and keep the saw moving forward, keeping it clear of your body. Always cut away from yourself, never towards yourself. With jigsaws, you're also able to make plunge cuts similar with the circular saw. And it's going to be in the same manner where you tilt it forward and then get the blade up to speed and then slowly plunge it in. And you can see this individual is doing a plunge cut here. This angle and everything and the way that it's set up, I would not recommend. Nonetheless, the base is up at an angle. Get your blade going, and you can see it'll start to grab in the wood. Once it starts to do that, you can start moving the base down. So as soon as it starts, this base comes down, it'll lay flat, and then you're able to continue your cut as you were before. Cut into the corner, back up about an inch, and turn a corner by cutting an arc. So anytime you cut corners with a jigsaw, let's say you're going to cut this, and let's say you start your plunge cut here, you start coming over, you never want to come up into your corner like this because then you have to stop and then do another plunge cut. But what you can do is, if you are going to cut a square shape, start your plunge cut here, and then what you do is little arcs for your corners, and then you're able to come in from this direction and it'll give you a nice straight and nice plumb cut, and you don't have to worry about overcutting. Reciprocating saws, also called sawzalls or saber saws, Use these for demo. You could use them for work to rough in. These do have different strokes that you can use. There are bimetallic blades out there that are available, so you can cut wood and metal, which is good if you're cutting nail embedded wood. Generally, the blade sizes range from 4 to 12 inches. And here you can see an example of a Sawzall being used. Looks like they're cutting down for this plate right here. It's used much like a jigsaw, but it's heavier, way more powerful. It's hard to cut to the line using this. If it's going to be something nice, don't use a Sawzall. Use another saw, as it says it's for rough work. Plunge cuts on these are a no-no. If you need to do that, drill a hole first and then you can start, but don't do a plunge cut with a Sawzall. Drills and drivers, we use these quite frequently in the class. Light duty drills have a pistol grip handle, which most screw guns and impacts that you use will have. Heavy duty drills have a spade shaped handle, also looks like a D, like the letter D. Drill size is determined by the capacity of the chuck, so you'll hear chuck size of 3/8, ½ inch, 5/8. Those are pretty common. Most drills have variable speeds and reversible controls. So impacts that we have levels 1, 2, and 3. They can go forward, they can go reverse. The drills that we have a wide variety of speeds, and there's clutch controls also. And again, forward and reverse. And here we're looking at some of the handles. So this one up here is a heavier duty one. It's the spade, or you can see it's the D-shaped handle. That allows you to get a better grip on it. And then down here, these are the pistol grip ones, which are more likely to hold with one hand. And some of them might have a spot on the collar up here if you want to put an additional handle. When you're using portable electric drills, always use the proper bit, insert, and tighten the chuck with the chuck key or by slowly spinning the chuck. Some drills don't have chuck keys anymore, especially the cordless ones. It's not very common. Hold small pieces securely by clamping or other means. So you can, if you're going to be drilling something and you need to make sure it's secured, you can use clamps, bar clamps, C-clamps. Or you can fasten it. You can use screws to hold it down or nails to tag it in place. Apply pressure as needed, but don't force the bit. If you force the bit, that could end up being a dangerous situation. I'm sure you may have seen videos out there where people fall through or fall down because they're pushing a drill or something of that nature too hard into something, and it ends up breaking and they end up falling. Twist drills are used in electric drills to make small holes in metal or wood, and those are your common drill bits that you see. A spade bit or a speed bore is used for boring holes in rough work. Those are similar to the augers that you've seen in the previous ones. Spade bits usually look something like this. And yeah, I'm not an artist, but instead of having the threads like an auger does, it just looks like this. And then all of these are your cutting surfaces, and this just keeps it in place. Forstner bit, you guys won't be using those in this class, so don't worry about that. Expansive bit bores, so over an inch in diameter. Again, the expansive bits we won't be using. And here's the expansive bits. Again, these we won't be using. The speed bores we will, and you can see here's your auger bits over here as well. And your Forstner style, we have these, but generally you won't be using them in the class. Countersink bit, this goes in with what we talked about in a previous screencast when you want to counterset stuff. And here's a drill and countersink combo, which is pretty common, so you're able to drill down to your desired depth, and then it countersinks it for you right away, so it gives you a nice finish. Hammer drills. The hammer drill that we have in here is cordless, 28 volt with a HEPA vacuum attached to it. The bits in a hammer drill are hammered as they rotate, and this works well in concrete and masonry. And ours is portable, which makes it really nice. And this is your typical hammer drill bit. And you can see on here, I'm just drilling into a concrete or masonry wall. Screw guns, which we use frequently in the class. Drywall drivers is one name, but we have separate ones just for drywall that we'll be going over the drywall portion of the class. You can use them for screwing gypsum board to walls, so drywall for walls, ceilings, but we also use them for a variety of tasks for what we're building in the class. And we use impacts quite a bit too. They're similar to light duty drills, except for a clutch that stops the bit turning when the screw is seated. Now, the ones that we have for drywall, they only drive in the screws to a certain depth, and then it disengages. And these are the ones used for drywall. Cordless drills, they're strong, convenient, and durable for any job. The ones that we have in here are Milwaukee. They use removable batteries and come with a variable speed reversing motors and positive clutches. If you didn't have clutches, you'd break something, right? It's just like a car where it allows some use without becoming dangerous. And instead of snapping back or grabbing too hard, the clutch will engage and then disengage the motor in the driving portion of the tool. Cordless circular saws can cut dimension lumber and are handy as trim saws, which they are when you're out in the field. And then here's some examples. You can see up here you have an impact. Here you have a sawzall. Here's your cordless hammer drill, a nice light so you can watch what you're doing, and a cordless circular saw. Safety is always the number one job of you and everyone else. Circular saws are a universal cutting tool, and they're also one of the more dangerous ones that you'll see on the job. Drills, drivers, and screw guns, so you could bore and fasten into almost any material. And cordless tools are convenient, strong, and durable.